This is How to Bond, Episode 1. Hello there. We are bonding. We will start off, excuse the camera, I'm holding it myself. We will start off with H2O. And yes, so first you have to draw the Lewis-Dot structure. H has one electron on it. Both H's have one. And O has 6 valence electrons. So once you group those, H follows, I believe, like the double rule, because you know there's the octet rule, and yeah. So it needs only 2 to be happy. So H gets that 2 from O, and another 2. The other H gets the 2 from O, and O's happy, and the H's are happy. So then you must do step number 3, which is checking if it satisfies the rule of 8. Now with H, it only needs 2 to be happy, therefore it will never satisfy the rule of 8. It will satisfy the rule of itself. So it's happy, ignore that smiley face. And O has 2 electrons, has 2 bonds with 4 electrons in it, and 2 pairs with 4 electrons in it, which has 8 electrons, which satisfies the rule of 8. Step 4, the table. You want to check for how many bonds it has. Usually you can do the table if the Lewis structure doesn't work, but in these steps I included it anyway. So you have H2 needs 4 to be happy, 2 for each H, and then O needs 8 to be happy. H has 1 electron each, so that's 2. O has 6. 12 minus 8 equals 4, divided by 2 equals 2 bonds. Step number 5, you must draw the Lewis structure. The Lewis structure, you would think it's linear, but since it has 2 pairs of electrons, which is 4 electrons on the O, it makes it bend. So it bends down and throws the H's down, so it has the O like that with 2 sets of electrons, then shows the bonds with H's, and that makes a bent shape. And that is H2O. Number 2. CCl4. You draw the Lewis-Dot structure. What you see is the C that has 4 electrons around it, and Cl that has 7 electrons around it because it has 7 valence electrons. In this, you see that one Cl is paired with an electron from C, making all of them happy. You go to the table to see if it satisfies the rule of 8. In C, there's 4 bonded, makes 8 valence electrons. And in all of the Cl, there's 1 bonded, 2 electrons. And then 3 pairs, 6 electrons, which adds up to 8 electrons, which makes them all satisfy the rule of 8. In the table, you see that it needs 8 to be happy. Cl, since there's 4 of them, needs 32. Valence electrons, there are 4 around C and 28 around Cl because 7 times 4 is 28. 40 minus 32, you add these up and add those up and subtract them. 8 divided by 2 equals 4 bonds, which you see that we have. Step number 5 is drawing the Lewis structure again. In this structure, you see that it forms, step number 6, a tetrahedral. That means tetra, the prefix for 4, there are 4 bonds around it. It goes to the side, up. This little shadow is showing it to the front, and this is showing it to the back. And that is how you bond CCl4. So H2. The Lewis-Dot structure, you see that each H has 1 electron. They need 2 to make an H happy, so them together make each other happy. You see that H has 1 bond, therefore 2 electrons, 0 pairs, so no electrons. Therefore, that does not satisfy the rule of 8. When you go to step 4, you see the H2, since there's 2 H's, each H needs 2 to make it happy, so 2 plus 2 is 4. Valence electrons, there's 1 each, so that's 2. 4 minus 2 is 2, divided by 2 is 1 bond. In the Lewis structure, you see that there's a single bond of the H's, and that makes it linear. H3O positive. The Lewis-Dot structure has 1 electron on each H and 6 on the O's. It can be drawn because there's 3 extra electrons with nothing to do with them, so you have to do the table. H3 needs 2 each to be happy, so that adds up to 6. 1 valence electron each adds up to 3. O needs 8 to be happy and has 6 valence electrons. The positive makes minus 1 valence electron. 14 minus 8 equals 6 divided by 2 is 3. The Lewis structure is drawn, and it is trigonal pyramid. The 2 electrons on the O makes these bend from that. They bend down and they form pyramid shape. Check for the rule of 8. And O has 3 bonds, 6 electrons each. 1 pair, 2 electrons each. Adds up to 8 electrons. With H, 1 bond, 2 electrons each in all of them. And they only need 2 to be happy, so it satisfies the rule of 8. In this, there is a charge, and the Lewis dot structure up here cannot be drawn to solve for the Lewis structure. Number 5, COCl2. The Lewis dot structure has 7 electrons around each Cl, 4 around carbon, and 6 around oxygen. Oxygen has 2 bonded, so that's 4 electrons, 2 pairs, 4 electrons each, adds up to 8 electrons. Carbon has 4 bonds, so 8 electrons each. Cl in both of them has 1 bond, 2 electrons, 3 pairs with 6 electrons, which adds up to 8 electrons, satisfying the rule of 8. In the chart, you see that oxygen needs 8 to be happy, 6 valence electrons. Carbon needs 8 to be happy, 4 valence electrons, and each Cl2 needs 8. Times 2 is 16, and 7 each adds up to 14 electrons. 32 minus 24 is 8, divided by 2 equals 4. In the Lewis structure, you see that there's a double bond from C to O, forming a trigonal planar. Single bonds going to Cl, and that is COCl2. All video editing was done by Tanisha with the help of the app Splice.